What is hybrid coordinate? Hybrid coordinate, remember, is hour angle declination, and observer coordinates are the zenith angle or altitude and azimuth. Now, many times instead of giving altitude, people give zenith angle. So, what is the relation? Zenith angle is 90 degree minus altitude. Okay, this is altitude. So, zenith angle is angle measured from zenith. So, if zenith angle is 0, means object is on zenith. If zenith angle is 90 degree, object is on, 90 degree minus 90 degree, object is on horizon, altitude will be 0. Okay, and so 90 degree minus altitude, fine, or I can write altitude is equal to 90 degree minus zenith. Both are equivalent. Okay, so if zenith angle is say 100 degree, what does it mean? The altitude is going to be 90 minus 100, so it will be 10 degree below horizon. So if zenith angle is more than 90 degree, you know that object is going to be below horizon. If zenith angle is positive, I mean between 0 to 90 degree, object is going to be above horizon. Okay, uh, and there is one important formula which is called equal to hour angle equal to sidereal minus right ascension, or right ascension plus hour angle equal to sidereal time. And to calculate sidereal time, there is a different kind of formula. So we'll talk about all these things now. So basically, it is a set of formula. Okay, right now we need not go into how this formula has come and how to solve this, because all goes into what is called spherical trigonometry. Okay, the trigonometry on the sphere. That itself is an interesting subject if you are interested in also the mathematics of this. But we can discuss that some other time. We want to use those formulae right now. So the first question: calculate the rising time for Vega at 18 hours 37 minutes 38 degree 48 minutes on 22nd December. Now this is given to, what is asked is at what time the Vega star will rise. Now see, there are what all coordinates are given to you. So alpha for Vega is given to you 18 hours 37 minutes. Declination is given to you 38 degree 48 minutes. And 22nd December is given to you. You don't know right now what to do with this 22nd December. Okay. So let me tell you how 22nd December is related to sidereal time. Okay. That is very essential for us. Now, I'm going to use one formula here because we want to find out the rising time. Let me go back to the earlier formula. Okay. And see here what happens. Okay. Uh, let us focus on two different formulae here. Let me change it to pointer. See, when the object is going to rise, it is on horizon, and therefore altitude is 0. So zenith angle is 90 degree. You agree with that? An object is going to rise or object is going to set, zenith angle is 90 degree, right?
Yes, sir.
Yeah. So look at this formula. Cos z is equal to tan sine delta sine phi plus cos delta cos phi cos h. Look at this formula. The left hand side is going to be 0. Cos z is going to be 0. So for rising of an object, while rising or setting, z is equal to 90 degree, cos z is equal to 0. And what I get here is this: 0 is equal to sine delta sine phi. Phi is your latitude, okay? Phi is the latitude. Plus cos delta cos phi cos h, which I can write as cos h into cos delta cos phi is equal to minus sin delta sin phi. And this cos delta cos phi I am going to divide. What it means is, while rising or setting, cos h is minus tan delta tan phi. And this is very, very useful formula, which we'll be using now. So while rising or setting, cos h is minus tan delta tan phi. So let me write that. Phi is 19 degree for Mumbai. Delta is already given to you. So cos h, while rising or setting for Vega, cos h is minus tan of 38 degree 48 minutes into tan of 19 degrees. And let us do this calculation and understand all these numbers ultimately lead to what. So I have 38.48 converted to degrees. So I mean full degrees. I calculate tan of this. I multiply with tan of 19. So 19 trigonometric tan. I press equal to. So I get this product. I change the sign. So I get minus tan delta tan phi. And this is my value. I want to calculate h. So h is cos inverse of this. So trigonometric second function cos inverse, I get 106 degrees. I want this is our angle. Our angle is written in our minute system. So I am going to divide this by 15 and I get 7.07 hours. Okay, 7.07 hours, which I can convert into hour minute seconds. So I click on DMS and I get 7 hour 4 minutes. So I'm going to write this as 7 hour 4 minutes. And you might have realized there is a problem here. What is the problem? Remember our definition of our angle, the time elapsed since the object was on the meridian. So if it is rising, it is not going to be something like, it is not going to be 7 hours. 7-hour time is for setting, because for setting also it is the same formula. So it is going to set when our angle is 7 hour 4 minutes. Rising angle has to be on the opposite side, the same formula, cos h was negative here, and therefore I have to subtract it from 360 degrees. So here I am going to subtract it from 24 hours. So this is going to be same as or 16 hour 56 minutes. I have subtracted 24 hour minus 7 hour 4 minutes. So 24 hour minus 7 hour is how much? 17 hours, and 17 hour minus 4 minutes is 16 hour 56 minutes. So this is the correct answer. The hour angle of rising is 16 hour 56 minutes. Now you may still ask, but what about 22nd December? What is this? That is because I am interested in the time. And this is giving me only hour angle. Hour angle only tells me that how many hours before it was on the meridian. That doesn't tell me the clock time. Okay. I want to convert it into clock time. And how do I do that? So for that I need this data. So what we know is we are going to use now next formula, hour angle plus right ascension is sidereal time. What is the right ascension? 18 hour 37 minutes. So even this coordinate is going to be useful now. Okay. So sidereal time, when it is going to set, when the star is going to rise, is 18 hour 37 minutes plus 16 hour 56 minutes. I strongly recommend you check this recording later again, because there are a lot of additional explanations are coming. So what is this sidereal time? This sidereal time is the sidereal time when Vega is going to rise. Okay, so the hour angle, now here nowhere up to this point we have talked about the date. Nowhere at up to this point we have talked about date. So every day sidereal time when the Vega is going to rise is going to be this addition. Okay, it is using hour angle of the star, and we are using a general formula which depends on the declination of the star, that at what hour angle it is going to rise. Okay, so sidereal time when the star is going to rise is this. Let me do the addition first. Okay, so this 56 minutes plus 37 minutes give me 1 hour 33 minutes. Okay, because it is more than 60. So 1 hour 33 minutes, and 18 plus 16 gives me 34 plus 1 35. So this is 35 hour 33 minute, which I can write. What is 35 hours 33 minutes? I have to subtract from 24 from this. Okay, because ultimately it has to be between 0 to 24 hours. So this becomes 11 hour 33 minute sidereal time. 11 hour 33 minutes sidereal time. So when the Vega is going to rise, that doesn't tell me what is the clock time. Now I have to look at 22nd December. On 22nd December, at what clock time sidereal time will be this much? That is what we have to bother about. And that is where one quick calculation comes. On this we have learned during our course. On 7th December, 7 p.m., sidereal time is double the month. In this case, it is December month. So 12th month multiplied by 2, that is 24 hours, or same as 0 hours. So on 7th December, 7 p.m., sidereal time is 0 hours. On 22nd December, at what time sidereal time will be this? That is the question. Okay, so let us do. Every day at the same clock hour, sidereal time increases by 4 minutes. You are going from 7th December to 22nd December, which is 15 extra days. Okay, so I'm going to say now after this, on 22nd December, sorry, this. Oh. Did I lose all the calculations? I lost all the calculations. Okay, let me do that. I remember the answer. Answer was is in the calculator. So what does that tell me? Our angle while was 7 hour 4 minutes. This is for setting, and for rising it becomes 24 minus this. So how much is it? 24 minus 7 is 17. So it is 16 hour 56 minutes. Sorry for that glitch. So our angle for rising, this is for rising. Okay, and I should call it this or this. This is for setting. So for rising, it is 16 hours 56 minutes. The right ascension value is 18 hour 37 minutes, and therefore hour angle plus right ascension gives me sidereal time, and sidereal time is 18 hour 37 minutes plus 16 hour 56 minutes. This we calculated as 35 hours 33 minutes, which I can write as 11 hours 33 minutes. Then I said 7th December 7 p.m. sidereal time is just a minute. Yeah, sidereal time is 2 into 12, that is 0 hour or 24 hours, same as 0 hours. Okay. So 22nd December 7 p.m. sidereal time. We have to add 4 minutes per day. So it is 0 hour plus 4 into 15 minutes. So that gives you 1 hour. So on 22nd December, 7 p.m. sidereal time is 1 hour. At what time it will be 11 hours, 33 minutes? That is the question. Okay. So it will become I think there is a mistake here. Okay, fine. See, it is after 10 hours, right? After 10 hours. So after 10 hours of 7 p.m., how much is the time? So 7 p.m. The difference is plus 10 hour 33 minutes. How much is this time? 7 p.m. plus 5 hours gives you midnight. So it is 5 hour
Yes.
33 minutes. Right? Is this fine?
Yes. In the
So
morning.
5 hour 33 minutes in the morning, Vega will be rising.